Hello everyone, my name's Logan and welcome back to the lecture hall. Whoa, sorry. So we are covering today what is a tangent, and we get into the Latin version of tangens. Tangens means to touch. So our tangent line is going to be a line that touches our curve, and it actually is going to touch our curve at one singular place. We know how to build lines out of equations with 2 points, right? We can take this point and let's say this point, and we can connect them and create a line. And this is what we call a secant line. We already know this from probably Algebra 2. So then we're like, okay, well, how do we find the slope of this line? Well, we know m is equal to y2 minus y1 over x2 minus x1. And we're like, okay, well, that's well and good, but we want our tangent line to touch at one point. And we're like, how do we do that in the first place? Well, we'd have to bring these points closer together, right? We could slowly bring these points closer together, thus getting closer and closer to our tangent line. So our tangent line is going to be a line that touches our curve at one specific place, and the slope of that line is going to be the slope of the function at that time. And this is where we get into derivatives. Derivatives are the slope of our function, right? Or the instantaneous equation of our slope. So we are going to use tangent lines a lot, and we are going to get our tangent lines from our derivatives. So to give a practical example of where we would try to find a tangent line, or where we may want to see it, is with position, velocity, and acceleration. They are actually deeply intertwined. We know that our position is our distance traveled, and then our velocity is going to be that distance over time, which is a slope, which is a rate of change, which is a derivative, which would give us some slope. So if we wanted to find what our velocity was at this point, well, we would just have to find, or like the tangent line of our velocity, we would find, okay, here, our change in our distance over time, that is going to be the slope of our tangent line. And so we can kind of talk about these things. We have position. Our derivative will give us our velocity, which is our change in our distance. And then our second derivative will actually give us our change in acceleration, which is our second derivative. So that's everything I wanted to cover in today's video. My name is Logan. Thanks for watching. Have a great day.